Dr. Jignesh Ji, Chairman, South Gujarat Local Center, Institute of Engineers, India. Today we are meeting for a wonderful topic, which is the current need, that is low carbon economy. The carbon, basically carbon dioxide, is a greenhouse gas, and we all aware of its ill effect. Today, whatever we are experiencing the change in the climate, one of the reason is CO2. And because of that, most of the countries in the world are going for the low carbon economy. And India is one of them. India is now going for the 5 trillion economy. And in that respect, the low carbon economy is very much important, because industrialization, whatever is going to be happening, it has to be with the care of environment. Otherwise, the environment is going to kill us. Their ill effect, already what we are seeing, it is going to be very severe. And from that point of view, today's session is very much important. For that purpose, we have 2 panelists with us, and it is very much excellent blend between the institute and industry. We have experienced Professor Sri K.H. Patel. He is currently head of Mechanical Engineering Department at Polytechnic Institute, Kosamba, and also he was previously a principal, Government Polytechnic, Navsari. He is having a rich experience of 40 years in technical education, especially Gujarat state. Second speaker is Mr. Dinanath Akela. He's very much experienced in a boiler. I will brief about his resume. He, after completion of BTech in Power Engineering from NPTI, Durgapur, in various well-known organizations, he started his career. Thermax, Usha Martin, Jamshedpur, IM FA Limited, Cuttack, and from last few years, he is working as manager operation in Hazira, MHD. He is having an experience in erection, commissioning, and operation in boiler, and he is also a competent person for inspection and certification of boiler. He is having so much achievements in his credit. He is given the beautiful talks which were praised all over the India in various technical and industrial platforms. So without taking much time, I request first panelist, Mr. Kamlesh H. Patel, to go with his talk. Thank you, sir.
Okay. Okay, sir. Am I audible?
Yes, sir. Yes, sir. Please proceed.
Okay. Good afternoon, all of you. I will start my webinar as the time permits less. So I will start the webinar with some background of this. With the webinar, with some background. As we know that the government started a smart city and smart villages project. But we simultaneously, we have a lot of challenges to address, in which with the development, the 80% of the population up to 2050 migrated to the city area, and the city area will be crowded, which will also create the environment problem, pollution problem along with this development. And that's why we have to adopt a low carbon economy. How to attain? So we have chosen this topic today for the discussion in this webinar. I will start my webinar. This is a low carbon economy. It is under the ISGS, India Smart Grid Forum. It is a government of India project. And some background is taken from that ISGF. So whatever the current development taking place in the context with the development of smart city and smart villages. For that, the first in my presentation, most probably GT will come. That is known as a gigaton. My topic of discussion is first introduction to pollution, then use of energy, then India's power sector overview, carbon credit, and then lastly we will discuss low carbon economy. We are facing in modern cities. Following points we have to address: poor air and water quality, insufficient water availability, waste disposal problems, and high energy consumption are exaggerated by the increasing population density and demand of urban environments. Strong city planning will be essential in managing this and other difficulties as the world's urban areas swells. Some pictures of pollution we will see. This is pollution by the automobiles and industry. Then this is a water pollution created. Screen share.
कौन सा ये है ना?
नीचे स्लाइड में से देखो ना। हाँ, परसेंटेज में कुछ होगा बड़ा प्लस माइनस करने का होता है उसमें लिखा कंट्रोल पॉइंट में तुम हाँ बस ठीक है ओके हो गया हाँ बस आप नेक्स्ट करते हैं।
Okay, this is the picture showing the pollution created by the industry and automobiles. Picture showing this is also one of the pollution to be addressed is noise pollution. Then this picture shows overall world is pollution is damaging the all over the world by industry, by automobiles and others. One of the problems I have taken, Delhi has one of the most rapidly growing automobiles market in the India with a number of vehicles having from 3 millions in 2007 to 88 millions, means 8.8 crores in 2050. Just taken comparison numbers. And in 2026 only 6 lakhs new vehicles added. So 32% increase compared to 2020. More than 4,027 buses carried 24.77 lakhs passenger per day on average in Delhi, and that will create an air index above 200. Number of hours for air quality index was good category if AIQ is less than 200. But in 2021, the position in Delhi is 827 out of 8760 hours. Means only 827 hours we have a good quality of air. In 2022, 1096 hours out of 8760 hours. So we can see that this problem is also with the most probably large cities, and it is now spread over to the small cities also. Solution is electrical vehicle. EV represent one of the most promising pathway to increase energy security, reducing carbon emission, and improve air quality. This is one of the pictures shows the Delhi air pollution when odd even implemented in 2019. This is the slide shows emission from the coal, oil, and gas. As China is one of the taking leading position in emission of carbon in gigaton. It is a slide of 2014. We can come today's situation. US, then India is in the 4th position, in which you can see the most probably pollution is created by coal. Means emission from coal is major part in all over the world countries. Energy consumption from renewable sources excluding hydro. This slide shows in EU, geothermal is more percentage. In US also. In China, most probably wind power is used as an energy consumption in renewable energy. India is also using wind as well as the solar, and then other countries are in the line. This one of the slide shows that how the carbon emission will be reduced if we will take the 1990 as 100%, and then the different sectors, power sectors, residential, industry, transport, non-CO2 agriculture, and non-CO2 other sectors. If we'll see this, the graph will decrease if we implement the green energy. Up to 2015, power sector will come down to 20%, residential and industry will come down to 15%, and transport will come down to 15 to 10%, and others will be less than 15%. India's power sectors overview. Indian electricity is powered by 4 sources: coal, renewable energy, natural gas, and nuclear energy. Close to 60% of India power generating capacity comes from coal. Renewable energy accounts for approximately 30% of the capacity, with natural gas, nuclear energy making up to the remaining 10%. This is a comparison of power generation, installed capacity in megawatt and percentage share, so we can have a clear picture about the development of the green energy sources in the power sector. If we'll take the example of 2019, out of 100%, renewable energy sources is 74,082. In 2021, 1 lakh, it reaches to 1,44,879, means 26.5%. And in 2022, it reaches to 29.2%. Simultaneously, if we will see on the coal side, in 2019, the power installed capacity or generating capacity is 54.7% share. Then it is reduced in 21 to 51.7, and in current situation 2022 49.9%. So this will shows the overall idea about the development of and implementation of green energy. India superpower in green energy, that will be some data. Last 6 months of the 2022, 7.4 gigawatt solar power generation carried out, 16 lakhs crore investment in green hydrogen in coming years, 700 gigawatt up to 2030 needs 41 lakhs crore investment, 1,491.4 billion units total generation in 21-22 in green from green energy, 7.96% growth in total generation in 21-22. It is the highest ever. This is also some data. The national electricity grid, India has installed capacity of 374.2 gigawatts as on 31st December 2020. Renewable power plants, which also include large hydroelectric plants, constitute 36.70% of the India total installed capacity. Is the world fifth largest over the last 5 years. In 2022, the capacity of renewable energy was 22.25 lakh megawatt. Some comparison of previous year also I have mentioned. In 2010, we have a 14,700 megawatt generation. In 2018, 86,000 megawatt plus 36,000 megawatt ongoing projects were there. In 22 December, total generation reached to 410 gigawatt. And in 2030, we will have a target to reach 700 gigawatt and reducing emission by 10,000 lakh ton as per the latest news. India is one of the world's second largest coal consumer after China and the third largest emitter of greenhouse gases. Coal-fired plants currently accounted over the half its nearly 373 gigawatt power generation capacity. Many of those plants are getting retired as per the Singh said at an industry event. Some plants are already retired and about 29 more plants are going to retire, and all that space will be occupied by the renewable energy. India, which aims to meet 40% of its energy requirement from non-fossil fuels sources by 2030, is targeting 50 gigawatt renewable based energy installed power and capacity by 2022. Meanwhile, in 2016-17, electricity generation from coal-based plant accounted more than 80% of the total power produced during the year. Private sector had a highest share. Private sector has had a highest share in coal-based generation, followed by the central and state sectors. By 2022, renewable are expected accounting for 33% of country's power generation and 60% by 2027. Renewable power production. One minute, please. This slide shows the solar power generation in Germany, India, Japan, and China. If we compare, the solar power generation in China is more still, but last 2 years, India is also going to leader. Solar power in the next 5 years, I have taken the data of previous years, 2012 to 16. Solar power in megawatt in India. See, in 16, we have a highest up to 300 megawatts power generation. India is aiming 100 gigawatt solar energy installed by 2022. It has potential about 750 gigawatt of solar energy at present till October 19, and the installed solar capacity is 31.69 gigawatt in December 12, 2009. The world will add 70,000 solar panels every year in next 5 years. According to the IES coal report 2021, India coal consumption will increase at an average annual rate of 3.9% to 1.18 billion ton in 2024 on the back of GDP growth rate of 7.4% between 2022 and 2024, which will partially fueled by coal. 70 December 2021. It is a data of 20 December 21. Now we will discuss about the low carbon economy. Now in the power sector, we have seen that still we are in the range of power generation by coal is more. And as the consumption of power is increasing day by day with the development, the coal power generation from coal is also increasing. Though we have limiting it, but still it is increasing. So we have to go for low carbon economy. So we will discuss about the low carbon. We will compare some parameters of power plant. If we will take the steam power plant, it has a 30 to 40% efficiency. Fuel and maintenance is high. Life is 30 to 40 years. Hydro, 80 to 90% efficiency. Water is a fuel, low maintenance, and 50 to 100 years of life. Nuclear, 55% efficiency. Fuel is uranium. Maintenance is very low, very high, and 40 to 60 years life. Diesel is 35% efficiency, and the fuel is diesel. Maintenance very high, and 10 to 20%. So if we'll compare this, we can see that all power plants from the non-renewable sources is up to 30 to 40% efficient. And that's why we are not getting much power from this type of sources. But in this comparison, you will see the grid connected renewable electricity, wind, total installed capacity megawatt is 34,000, and 22 target is 60,000. Solar 21,651. Target in 2022 is 1 lakh. Biomass 8701. Target is 10,000, and small hydro. In that category, we don't have much development. And all this, wind is 40% at 9 meter per second, and solar is working at 20% efficiency. Now, what is low carbon economy? We'll discuss. Low carbon economy refers to an economy that has a minimal output of greenhouse gas into the biosphere, namely an economical model based on small energy consumption, low environment pollution, low carbon emission and is important progress of human being after agriculture and industrial civilization. Briefly, the low carbon economy refers to the green economy based on low energy consumption and low pollution. The nature of low carbon economy is important progress of human being after agriculture and industrial civilization. When we talk about the low carbon economy, we have to know about the carbon credit. A carbon credit is the generic term for any tradable certificate or permits representing the right to emit 1 ton of carbon dioxide or the mass of another greenhouse gas with carbon dioxide equivalent to 1 ton of carbon dioxide. It is traded on the European Climate Exchange, and therefore you emit 1 ton less, you will get 22 euro. Emit less and increase or add your profit. This is the base of carbon credit. The new study shows that $185 per ton of CO2 means this will be the $185 will get 1 ton of carbon CO2 less emission. The global carbon credit market was valued at US $211.5 billion in 2019 and is expected to reach US $2,407.8 billion by 2027 at CAGR of 30.7 between 2020 to 2027. We at MCX decided to trade carbon credit because we are in the future trading. Some example of carbon credit earned by the different power plants at Mithapur plant would help to reducing the annual average of 37,696 ton of carbon dioxide by producing 39,597 megawatt per year average equivalent amount of clean energy. It is by Tata Power. Adani Power is also at Mundra Power Plant on 600 crore carbon credit. This is the world's first coal fire plant that will receiving carbon credit. The company is going to set a power plant with a capacity of 4,620 megawatt, which will be completed in 4 phases at present. All the 4 units of phase 1 and phase 2, total capacity of 1,320 megawatt based on subcritical technology have been commissioned and are commercially operational, says by the company. It is going to add another 2,640 megawatt of capacity in 2 phases. It is phase 3 of the Mundra project, which also based on the supercritical technology. We will discuss supercritical technology at the end by has received a clean development mechanism CDM known as project certification from United Nations framework convention on climate changes. Similarly, with other power plant, we will discuss Torrent Power, Adani Power, JSW Steel, own power plant reducing equipment. The most tradable credits in India up to 2020, they may win more than 77 million credits valued at about 400 million euros based on their December 90 closing price according to the data compiled from Bloomberg. Hindalco Novelis invest rupees 373 crores to build a recycling center with an annual casting capacity of 100 kilotons of low carbon CT ignore and at the Ulsan Aluminium Joint Venture in South Korea. It will reduce carbon emission by more than 420,000 tons each year. $1 million equal to 6.4 crores. This is just comparison to more. Now, if you will compare the GDP of last 5 years, 18-19 we have a 6.5%, 19-20 3.7%, 20-21 6.6%, and 20-21 8.7%, and 22-23 7%. 1 kilowatt of energy generated by any solar photovoltaic power plant equivalent to 0.932 kg of carbon dioxide reduction. Taking this average value, kg of carbon dioxide emission reduction per kilowatt hour for the solar PV plant installed in India. Now, to attain the low carbon economy, along with the carbon credit earning, smart grid era of low carbon economy is to be addressed. India plans to invest billions of dollars in smart grid developments over the next 10 years as a part of ambitious plan to achieve low carbon economic growth. These would be fueled by the government plan of setting up 100 smart cities and 500 smart towns. The challenges of climate change and the continued growth of electricity demand are putting increasing stress on India electricity network infrastructure. So that should be also addressed. India is now at the point of transition in the new era, which clean energy will be at the premium. Networks will need to flexible to incorporate of new low carbon technologies, and customers will demand greater insight and control over their own consumption. Means all the customers just now, they have a one-way utilization, but now with this development, they have a control over their own consumption, just like a mobile. Smart grid represents evolution of electricity network from generation to consumption in a way that is interactive, flexible, and efficient. The challenges include the integrating renewable to intermittent power from large-scale plant, often located far from the consumer, and from small-scale installation. Smart grids are crucial to some of the Indian government key projects. 100 smart cities are already in the development stage. 50 gigawatt of renewable energy we have achieved in 2022. 60% of renewable energy installed capacity by 2030. Electric vehicle to combat the air pollution, and 24/7 power supplies. The development of the fully fledged low carbon economy will require changes in the core electricity infrastructure. That is also going on with the smart city development. To successful transition to a full-fledged low carbon economy, the core infrastructure transition and distribution of electricity need to be addressed. Smart technologies means along with this, the smart technologies will be a necessity of this transformation. Applying telecommunication and computing technologies developed over the last 2 decades to the current and future electricity infrastructure. The existing distribution of grid infrastructure is primarily designed for one-way flow of the electricity and limited consumption in the home. With the growing implementation of large-scale and intermittent renewable energy generation and distribution generation and electric vehicle, the operational limits of the network as it is currently designed will be reached. To avoid stalling progress towards the sustainable and low carbon future, necessary investment must be made in power grid and the infrastructure that will effectively, without significant operational constraint, accommodate this technology at a large scale deployment. India is working on several futuristic fronts to find a solution to meet the energy needs. Smart grids are one of the several aspects of the solution in meeting the increasing energy demand of the country and supplying 24/7 reliable power to all citizens. In 2021, over 6K smart city projects worth 1,84,998 crore tender, and this Indian government launches the smart city mission in June 15. Around 100 smart cities were selected between January 2016 to June 2018 through 4 rounds of competition. 16 December 21 data. Now let us have some discussion in the new updates on the energy sector. Ashok Leyland, the auto arm of the Hinduja Group, said it's signed the letter of intent with Finagri, an Israel-based company that is developing aluminum air batteries for long-range vehicles. Unlike lithium-ion batteries, which need to be recharged after 200-500 kilometers, a vehicle that uses aluminum air battery can run or several thousand kilometers. Another advantage is that energy to weight ratio of the aluminum air batteries is far higher than that of the lithium-ion batteries. Lithium-ion battery that is designed to last for the entire duration of the cross-country truck route will weigh as much as the truck itself, but not in the case of aluminum air batteries. So this is also one of the important development in the battery side. Finagri claims that the energy weight ratio of 8 kilowatt hour means 8,000 watt hours of stored electricity per kg of aluminum. A typical lithium ion battery stores only 150 means 150 watt hours per kg. So this is the comparison we can see that in aluminum air batteries will be more suitable for next generation. The higher storage to weight ratio could make the solution grid independent as the vehicle can run for up to the day on a single battery charge. The downside of this battery is that they cannot be recharged at home. To recharge them, their anode has to be mechanically replaced with a new ones only. One of the other development in the field of atomic power station, Kakrapar Atomic Power Station installed largest nuclear reactor, 1,400 megawatt, produce 1.68 crore of unit electricity using 3 kg uranium. This is one of the most newly developed technology, which is equivalent to 6,600 metric tons of coal. And this reactor is earthquake and missile attack proof. So this is also one of the important point to be addressed. This is the photograph shows the EV. Some data regarding the charging and carbon emission comparison. If you will see fuel type CO2 emission per kg per kilometer, if we will see the petrol 0.23251, if diesel 0.273, if we'll see the electric vehicle, it is only 0.1. So carbon emission is very much reduced. This is the charging rate. Okay. In charging rate, this is the table. If we will see the latest different kind of like development takes place, which will reduce the maximum charging rate. See, this is up to 2C. Then if lithium ion, nickel, manganese, cobalt is C/2, lithium ion, nickel, manganese, cobalt 3C, lithium, nickel, cobalt 2C. This is the maximum charging rate. Okay. And this is the maximum temperature it can withstand. Lithium, titanium 6C. Life, if we'll see in that case, the lithium ion, nickel, and manganese, cobalt is 3,000 to 4,000 cycles, life cycles. And this is the power density we can compare, and average module price. So if we will see the module price, as the lithium ion nickel battery is very good for use, then it has cost also more. But if you will see the last lithium ion titanium battery, then it costing 700 per kilowatt. This is one of the latest paper cutting. The selling of the EVs, it is very fast. In 2017-18, if you compare 69,000, 18-19, 1,43,000, 19-20, 1,67,000, 20-21, 2,36,000, and 21-22, 3,29,000 electric vehicles selling. This data shows that the transition towards the use of electric vehicles. We have some film.
Improvements. Landholding consultant. Sunil Panchal okay. Sunil Panchal has a 30 years of learning. I call it a learning, not experience.
ये वीडियो फिल्म ये क्या ऐसा होता है, ये रन करने
रन कीजिए। ये तो डेस्कटॉप पे है बाहर।
हाँ नहीं फिर इधर है
कौन ये फाइल डेस्कटॉप पे
नहीं है, इधर से रन करो।
इधर से नहीं हो रहा है ना। हाँ हो रहा है।
होगा नहीं आ रहा।
15 kilograms per square meter. The liquid nature of the organic polymer means it can be printed from printers, much like those used to mass-produce newspapers.
Just we are connecting. We are just going to play one the short videos, right?
Check here. Okay. Yeah. Presentation is like. Yeah.
These ultra-thin solar panels can be printed like newspapers. The University of Newcastle, Australia has created printable photovoltaic solar cells, which could revolutionize urban power generation. The panels, which are only 0.075 millimeters thick, were created with proprietary technology, making use of organic polymers, which can capture solar energy and conduct electricity. Traditional photovoltaic solar panels rely on silicon to carry out these functions and can often weigh up to 15 kilograms per square meter. The liquid nature of the organic polymer means it can be printed from printers, much like those used to mass-produce newspapers and books. According to University of Newcastle physics professor Paul Dastuer, printed solar technology has a number of broad applications, such as power for street lights, water pumps, disaster shelters, camping equipment, building smart blinds for buildings, and even powering vehicles. The cost of production is also much cheaper than traditional panels, coming in at around 10 Australian dollars per square meter. A full-scale commercial plant could print kilometers of solar panels a day. The printed sheets can also be stuck with a special adhesive tape to a variety of surfaces, meaning no expensive and intrusive installation methods. The tech is currently on public display at the Canopy in Lane Cove on Sydney's North Shore. The panels, which are attached to a covered walkway, generate power for a series of lights that come on at night and track passers-by with sensors. What do you think about the printed solar tech?
One more video of interview, just current interview given by the Sri Gadkari sir, that we will see regarding the low carbon economy, and that will have a clear-cut idea about the low carbon economy implementation in India. ये कर नहीं एक मिनट ये हाँ फर्स्ट अभी देखो
यहीं से
सरप्लस, एक समय फूड वर्सेस फ्यूल ऐसा विवाद होता था। अब हमारी एमएसपी ज्यादा है और मार्केट प्राइस कम है, तो हमने ये किया है कि डाइवर्सिफिकेशन ऑफ एग्रीकल्चर टुवर्ड्स एनर्जी एंड पावर सेक्टर। हमारा किसान केवल अन्नदाता नहीं बने, ऊर्जादाता बने, और मैंने ऐसे अनेक उपक्रम अभी लिए हैं। पहली बात, हम लोग शुगर के जूस से इथेनॉल बना रहे हैं, फिर सी मोलाइसिस से इथेनॉल बना रहे हैं, फिर बी हेवी मोलाइसिस से इथेनॉल बना रहे हैं, फिर कॉर्न राइस उससे इथेनॉल बना रहे हैं। हमारे देश में 450 करोड़ लीटर इथेनॉल होता है। जब हम पेट्रोल में 20% डालेंगे तो हमको 1000 करोड़ लीटर लगेगा। हमारे जो आईटी टावर्स के जो जनरेटर है जो डीजल पर चल रहे हैं, उसमें हमारे यहाँ 2000 करोड़ लीटर डीजल लगता है। और अभी मैंने ही ऐसे एक बार मेरे ध्यान में आया कि रशिया में इथेनॉल का माइलेज और पेट्रोल का माइलेज सेम हो, क्योंकि 1 लीटर ऑफ पेट्रोल इक्वल टू 1 लीटर 300 ml ऑफ इथेनॉल। तो मैंने टेक्नोलॉजी रशियन साइंटिस्ट को बुलाया और पेट्रोलियम मिनिस्टर, इंडियन ऑयल के चेयरमैन वैद्य साहब और राम कुमार जो है उनको प्रेजेंटेशन दिया। तो सब होने के बाद उन्होंने कहा कि आइडिया इज वेरी फैंटास्टिक, बट इट सीम्स टू बी इट इज वेरी डिफिकल्ट। तो मैंने फिर हिंदी में उनको कहा कि गाजर की, उनके सामने बोल रहा था, गाजर की पुंगी है, बच गई तो बजाओ, नहीं तो खा लो। वो 3 महीने के बाद प्रूव हो गया। अब इथेनॉल का माइलेज और पेट्रोल का सेम है। इथेनॉल का रेट 60 रुपए, पेट्रोल का 120 रुपए। अब टोयोटो की गाड़ी मेरे पास है, और अब टोयोटो पूरी मॉल, जो कैम्ब्री करके गाड़ी थी जो पेट्रोल में जाकर 40% बिजली तैयार करती थी, वो अब 100% इथेनॉल पर चलेगी और बिजली तैयार करेगी। यानी पेट्रोल का भाव 25 रुपए जो आता है उस हिसाब से एवरेज मिलेगा। अब मर्सिडीज, BMW सब फ्लेक्स इंजन ला रहे हैं। अभी बजाज, टीवीएस और हीरो इन्होंने, और होंडा, इन्होंने उनकी मोटरसाइकिल, स्कूटर फ्लेक्स इंजन में बनाई इथेनॉल पर। अब हमारे देश में इथेनॉल एग्रीकल्चर में बनेगा, उसके कारण हमारा एग्रीकल्चर का ग्रोथ रेट केवल 12% है। 22 से 24% मैन्युफैक्चरिंग सेक्टर का है और 52 से 54% सर्विस सेक्टर का है। इथेनॉल ये जो फ्यूल है, सीएनजी, जैसे भी परली है, इंडियन ऑयल ने पानीपत में प्रोजेक्ट डाला है 1 लाख लीटर इथेनॉल और 150 टन बायोबिटुमिन। अब मैं एक सेंट्रल रिसर्च ऑर्गेनाइजेशन और अपने CSR ने मुझे प्रेजेंट दिया, मैं उसको पॉपुलर कर रहा हूं कि परली जलाने से दिल्ली में आपको मालूम है पोल्यूशन हो रहा है, बर्निंग करने से। अब परली से 70% बायोबिटुमिन, जिसमें 8 फीचर्स ऐसे हैं जो पेट्रोलियम बिटुमिन से अच्छा है, और 30% बायोचार यानी कोल, जो ऑर्गेनिक कार्बन है, जो एग्रीकल्चर के लिए उपयोगी है। अब मुझे बताइए, देश में 80 लाख टन बिटुमिन लगता है, 50 लाख टन बिटुमिन रिफाइनरी देती है, 30 लाख टन हम इंपोर्ट करते हैं। अब ये ट्रैक्टर मोल्डेड यूनिट अगर हरियाणा, पंजाब के हर गांव में लग गया और बायोबिटुमिन तैयार होगा, तो वैसे मैं तो इंडियन ऑयल को बोला कि पूरा हम खरीद लेंगे, तो 30 लाख टन का इंपोर्ट बचेगा, यहाँ रोजगार निर्माण होगा, एग्रीकल्चर में परचेसिंग पावर बढ़ेगी और इन्वायरमेंट का प्रॉब्लम सॉल्व होगा। इंपोर्ट सब्स्टिट्यूट, कॉस्ट इफेक्टिव, पोल्यूशन फ्री और इंडिजिनियस। वैसे अभी पेट्रोलियम मंत्री जी ने कहा कि केवल हमने इथेनॉल ऐड करने से अब जो रेट बढ़े, उसमें हमारा 40,000 करोड़ रुपए का फायदा हुआ। और आज आपको मैं बताता हूं कि हम 16 लाख करोड़ का इंपोर्ट फॉसिल फ्यूल का कर रहे हैं, और उसके बदले में पोल्यूशन पूरा है, जिसके कारण हमारे हेल्थ प्रॉब्लम क्या हो रहे हैं। तो दिस इज द टाइम। अभी 5 टन ऑफ परली इज गिविंग 1 टन ऑफ बायो CNG एंड बायो LNG। और मैंने कल ही ऑटो एक्सपो का उद्घाटन किया, आप जरूर उसको जाओ। इलेक्ट्रिक कार, फ्लेक्स इंजन, स्कूटर्स सब आ गया। और वो मोटर, मुझे वो सियाम वाले सब कहते थे, मैं जब उनको बोलता था Euro 6 का नॉर्म चाहिए, तो मेरे ऊपर नाराज होते। मैं आए तो भी तुम्हारे साथ, नहीं आए तो तुम्हारे बिना बुलडोज करूंगा। अब कल उन्होंने पूरा ग्रीन एनर्जी का पैवेलियन बनाया था। मुझे इतनी खुशी हुई कि वो दिन अब दूर नहीं है कि ये 16 लाख करोड़ का इंपोर्ट कम होगा, और कम से कम 7 से 8 लाख करोड़ अगर एग्रीकल्चर सेक्टर में जाएंगी, तो ये 12% एग्रीकल्चर ग्रोथ रेट अगर 18 से 20% में गएगा, तो आत्मनिर्भर भारत का प्रधानमंत्री का सपना पूरा होगा। तो इंपोर्ट सब्स्टिट्यूट, कॉस्ट इफेक्टिव, पोल्यूशन फ्री और इंडिजिनियस, ये अब सक्सेस स्टोरी बन रही है। दूसरी बात ग्रीन हाइड्रोजन की है, वो भी बहुत इंपॉर्टेंट है। जो पेट्रोलियम से बनता है वो ब्राउन हाइड्रोजन, जो कोल से बनता है वो ब्लैक हाइड्रोजन, और जो ग्रीन हाइड्रोजन है वो 3 है। और सरकार ने 20,000 करोड़ हाइड्रोजन मिशन के लिए रखे हैं। अब जैसे पानी से, मैंने अभी आपको उल्लेख किया था कि मथुरा में मैंने हाइब्रिड एन्युटी में ATMLD स्लज को त्रिवेणी इंजीनियरिंग ने लिया है और वो प्रोजेक्ट सक्सेसफुल हो गया। 20 करोड़ इंडियन ऑयल वो पानी खरीदता है और वो हाइब्रिड एन्युटी में सक्सेस हुआ। तो अभी रूफटॉप सोलर, क्योंकि पानी से जब बनाएंगे तो हमें बिजली 70% लगती है, तो रूफटॉप सोलर में बिजली की कॉस्ट कम है। और इलेक्ट्रोलाइजर में इंडिया इज नंबर 1 इन द वर्ल्ड इन मैन्युफैक्चरिंग ऑफ इलेक्ट्रोलाइजर। हम 90%, एक बंगलोर की कंपनी है, पूरा एक्सपोर्ट करती है। और इलेक्ट्रोलाइजर से ये करेंगे, ये हाइड्रोजन की कॉस्ट थोड़ी ज्यादा आ रही है। फिर इसके साथ जो बायोमास है या ऑर्गेनिक वेस्ट है कारपोरेशन की, म्यूनिसिपल वेस्ट, ये बायोडाइजेस्टर में डाल के मीथेन निकालकर फिर हाइड्रोजन निकलता है। तीसरा जो मैंने एक 4 दिन पहले बेंगलोर में देखा, इंडियन इंस्टीट्यूट ऑफ साइंस बेंगलोर में, उन्होंने बायोमास से ग्रीन हाइड्रोजन बनाया। मेरा जो एक्सपेक्टेशन है कि हमारा ग्रीन हाइड्रोजन 100 रुपए किलो मिले। अगर 100 रुपए किलो अगर ग्रीन हाइड्रोजन होगा तो 1 लीटर में वो 450, 1 किलो में 450 किलोमीटर चलता है। मेरे पास ग्रीन हाइड्रोजन की कार है टोयोटा की, उसका नाम है मिराई। मिराई मीन्स भविष्य। दिल्ली आओ, मैं एक बार घुमाऊंगा, मर्सिडीज से अच्छे इफेक्ट्स है। तो ये ग्रीन हाइड्रोजन इज द फ्यूचर फॉर द कंट्री। और हिंदुस्तान ये एनर्जी को इंपोर्ट करने वाला नहीं, तो एनर्जी को निर्यात करने वाला देश बनेगा। हमारी रेलवे, हवाई जहाज, हमारी गाड़ियां, ट्रक, बसेस, हमारा स्टील, केमिकल्स, सब उसके ऊपर चलेगी। और 10 साल में पूरा ये इंपोर्ट खत्म हो जाएगा, पोल्यूशन भी खत्म हो जाएगा। और दूसरा, एग्रीकल्चर में एकदम रिफॉर्म हो जाएगा। मैं आपको बता रहा हूं कि ये इतनी सक्सेस स्टोरी है कि गांव में मेरी अपनी आइडिया, क्योंकि
देखा ना?
और वहां है, कोई टेक्सला से कम नहीं है। टेक्सला का स्वागत है, रेड कारपेट है। पर वो कहेंगे कि चाइना में बनाएंगे और हिंदुस्तान में बेचेंगे और उनको कंसेशन मिले, ये कैसे संभव है? वो हिंदुस्तान में मैन्युफैक्चरिंग करें। हमारी 7.5 लाख करोड़ की ऑटोमोबाइल इंडस्ट्री है। देश को सबसे ज्यादा जीएसटी स्टेट गवर्नमेंट और भारत सरकार को देने वाली ऑटोमोबाइल इंडस्ट्री, 4.5 करोड़ युवकों को जॉब देने वाली इंडस्ट्री ऑटोमोबाइल इंडस्ट्री, हमारा एक्सपोर्ट सबसे ज्यादा करने वाली ऑटोमोबाइल इंडस्ट्री। और आज मैं आपको बताता हूं, मैं ये बात कह चुका हूं कि पहले हम वर्ल्ड में चौथे नंबर पे थे। पहले नंबर पर यूएसए था, दूसरे नंबर पर पहले नंबर पर चाइना था, दूसरे नंबर पर यूएसए था, तीसरे नंबर पर जापान था, चौथे पर हम था। अब मैं इस विभाग का मंत्री हूं, मुझे बहुत खुशी है, कल मैंने सभी स्टेक होल्डर्स को धन्यवाद दिए। अब हम जापान को पीछे डालकर तीसरे नंबर पर गए। अब इलेक्ट्रिक, इथेनॉल, मिथेनॉल, बायोडीजल, बायो एलएनजी, बायो सीएनजी और इलेक्ट्रिक बसेस, इलेक्ट्रिक ट्रक सब मैंने देखी, हाइड्रोजन। मैं आपको बताता हूं कि 5 साल के अंदर, वैसे मैं बोलता हूं वो बातें 100% होती है, तो 5 साल के अंदर वर्ल्ड में नंबर 1 का ऑटोमोबाइल मैन्युफैक्चरिंग हब इंडिया बनेगा और इंडिया से सब एक्सपोर्ट होगा।
हम लोग बिजनेस टुडे के बैंकिंग समिट में बैठे, सुबह से जो सेशंस हो रहे थे उसमें चर्चा कई मर्तबा इस बात पे हुई कि जो होलसेल क्रेडिट ऑफटेक है, यानी कि जो कि बड़े उद्योग हैं वो कितना पैसा इन्वेस्ट कर रहे हैं इंडिया की स्टोरी में। जब आपकी सरकार ने कॉर्पोरेट टैक्स को,
एक बात सच है कि हमारे यहाँ मोदी जी के नेतृत्व में हमने जो लिबरल इकोनॉमिक पॉलिसी को स्वीकार किया है, उससे बड़े प्रमाण पर ये टेक्नोलॉजी आ रही है। पर 2 बातें जरूरी है, इनोवेशन, एंटरप्रेन्योरशिप, साइंस, टेक्नोलॉजी, रिसर्च, स्किल्ड एंड सक्सेसफुल प्रैक्टिसेस, वी नेम इट एज नॉलेज एंड कन्वर्शन ऑफ नॉलेज इनटू वेल्थ इज द फ्यूचर। एंड सेकंड थिंग इज, नो वन इज बेस्ट, no person is best. It is depending upon appropriate technology and appropriate vision of the leadership that you can convert waste into wealth. तो मुझे 2 बातों पे लगता है कि हमने ऐसे क्षेत्र चुनने चाहिए जिसमें हमारी कंपनियां जॉइंट वेंचर कोलैबोरेशन करें और टेक्नोलॉजी को लाएं। वर्ल्ड की बेस्ट टेक्नोलॉजी हमारे देश में रहे, इससे हमारा एक्सपोर्ट बढ़ेगा। दूसरी जो इंपॉर्टेंट चीज हम कर रहे हैं कि हमारी लॉजिस्टिक कॉस्ट 16% है और हमारे एक्सपोर्ट के लिए बड़ी अड़चन का विषय है। प्रधानमंत्री जी ने कहा कि हमको सिंगल डिजिट में जाना है, और आज मुझे खुशी है कि मैं 1 साल के बाद, आप मेरा जरूर इंटरव्यू लेना, तब मेरी बातों को रिकॉर्ड करके रखना। दिल्ली से देहरादून 2 घंटे में, दिल्ली से जयपुर 2 घंटे में, दिल्ली से हरिद्वार 2 घंटे में, दिल्ली से अमृतसर 4 घंटे में, दिल्ली से श्रीनगर 8 घंटे में, दिल्ली से कटरा 6 घंटे में, बेंगलोर से चेन्नई 2 घंटे में, नागपुर से पुणे 6 घंटे में, नागपुर से मुंबई 6 घंटे में, अब 24 घंटे लगते हैं, और बेंगलोर से मैसूर 1 घंटे में। तो पूरे देश में भी ऐसे 32 ग्रीन हाईवे बना रहा हूं मैं। तो लॉजिस्टिक कॉस्ट जो है वो 100%, 10% के नीचे आएगी। और हम फ्यूल कौन सा यूज कर रहे हैं? एलएनजी। अभी एलएनजी में अगर आज ट्रक चलाएंगे तो डीजल का जितना खर्चा है उसके 40% एलएनजी पे ट्रक चलता है। अब ब्लू एनर्जी के ट्रक अभी आ गए, अभी कल वो कुमिंस कंपनी के आए, टाटा के आए, लेलैंड के आए। अब एलएनजी बनेगा परली से, और वैसे इंपोर्टेड भी करना पड़ा, एकदम इतना नहीं बनेगा। तो नेचुरली लॉजिस्टिक कॉस्ट कम होगी। दूसरा, एक ट्रक अब दिल्ली से मुंबई 12 घंटे के बजाय कार आती है वो 18 घंटे लगेंगे, अभी 48 घंटे लग रहे हैं। तो एक ट्रक जो महीने में 4 बार या 5 बार आता था वो 8 से 9 बार आएगा, तो कॉस्ट कम हो जाएगी। मैं आपको बताता हूं ऐसा थोड़ा सा प्रॉब्लमेटिक हो जाएगा, क्योंकि हमारी पहली प्रायोरिटी है वाटरवेज को। 10 रुपए खर्चा अगर लगता है रोड पे तो पानी पे 1 रुपया लगता है। तो पहली प्रायोरिटी वाटरवेज, सेकंड प्रायोरिटी रेलवे, थर्ड प्रायोरिटी रोड और बाद में एविएशन। पर मेरे को डर है कि 1 साल के अंदर रेलवे के रेट के हिसाब से रोड का रेट कम हो जाएगा, और वो कम होने से फिर वो थोड़ा इम्बैलेंस हो सकता है। तो रेलवे भी कुछ सुधार करेगी, वो डबल कंटेनर लेके गाड़ी लेके जाएगी, तो ये अच्छी है कंपटीशन है। तो लॉजिस्टिक कॉस्ट को कम करने से एक्सपोर्ट बढ़ेगा। और टेक इकोनॉमी ये हमारी सबसे बड़ी स्ट्रेंथ है। हमारे आईटी इंजीनियर्स ने, सॉफ्टवेयर इंजीनियर वर्ल्ड में साबित कर दिया कि हमारे पास इतनी कितनी बड़ी क्षमता है। हमारे डॉक्टर्स यूरोप और अमेरिका में 10 में से 4 भारतीय है, और सबसे यंग टैलेंटेड इंजीनियरिंग मैन पावर किसी देश में तो हिंदुस्तान में है। तो टेक्नोलॉजी रिसर्च उनको मिला, तो मैंने कहा आपने तो मेरे ऊपर एडिटोरियल लिखा था, सीनियर जर्नलिस्ट, उन्होंने कहा हमको एक्सपेक्टेशन ही नहीं था ऐसा हो सकता है। नागपुर इज ए टाइगर कैपिटल। हमारे पास 2.5 घंटे के डिस्टेंस पर 350 टाइगर है। अब हमारा फॉरेस्ट एक्टिव हो गया, अब दुनिया भर के लोग टाइगर देखा। एग्रीकल्चर है वो ओली, मैंने आपको बताया अभी, ओली ये डावस से अच्छा है, और वहां हम लोग इतना अच्छा टूरिज्म करते हैं। अभी मैं
कल ही डावोस जा रहा हूँ, बोल रहे ओली डावोस से अच्छा, वहां का इंफ्रास्ट्रक्चर देखा है आपने स्कीइंग का?
So we'll stop here, and the last slide I will show you the today's news in Divya Bhaskar that 11th state of India has started selling of petrol with 20% ethanol, saves 53,894 crore import. So this is latest news regarding to the our low carbon economy. Thank you all for hearing me silently, and I will switch over to Mr. Akela for further presentation.
Fine. Thank you, Kamlesh sir, and thank you to all of the audience. Right now, I'm just connecting to my slides. Right, so just please wait for some minutes. Thank you, Kamlesh sir, and to all of the audience. So once again, welcome to all of you. I think my voice is audible, right? So just now I'm connecting to the PPT, right? And here I'm going to discuss in the detail about the low carbon economy in the context of the future fuel of the green hydrogen, right? And yes, we have the development we have done, and still we are progressing in the fast rate in this the green hydrogen, right? So just I'm going to share you some interesting facts which we have still we have received. So first I'm just going to share about the thoughts of the Mukesh Ambani, that he told about the India can set a even more aggressive target of under $1 per kg of hydrogen in 1 decade. So that's why it is mentioned about 111, the 111 as a target for the green hydrogen. Apart from the Renew Power, IOCL, they have also making the process of what we can. They are going to start for this the generation of hydrogen. And the latest what we can say the development for Atmanirbhar Bharat from the Reliance Industries, they have set it and they have achieved that the combustion of hydrogen in the trucks, right? So just very small videos. Just I'm going to share to you, right? So this was the latest development from the Reliance industry, and some more details about that the India is now in the position that has the target for the national green energy hydrogen missions, which will establish the India as a global market leader, right? So now I'm coming to the main topic about how these things to be going to be happen and what we have to plan for. To achieving this all the initiatives and the target, right? So first of all, I'm going to discuss about the how the worth of this green hydrogens, right? What are the government initiatives that going to be held for the green hydrogen missions, and what are the challenges and what the possibilities of this the combustion technology of the hydrogen, right? So in this point I'm going to share each and every detail to all of you, right? So just with me. So as we know a little bit the details about the hydrogen, right? So if what we can say, it is available in the atmosphere, and it is having the huge amount of the calorific value. So per kg of hydrogen combustions, we are approximately able to get the 28,922 kilocalorie. If this thing, if we compare with other the fuel like the natural gases, then we can say it is 2.5 times as the ratio of the energy per ton Yes. So this is the detail about the combustion. So C plus O2, so it is going to be combustion of CO2, then it is only going to liberate of 8084. But if you see here, the hydrogen is going to be combustion, then it is going to produce the H2O, that is the water, and it is going to produce of 28,922 kilocalorie of heat, right? So but how this things is going to be going on, and the one base what are the features of hydrogens are there? So basically it is available, or it is going to be stored at a very high pressure, so that what we can say, it is converted into the liquid state, right? So that is also a little bit right now the challenge of to maintain and to store at a pressure of 800 bar. So it is a really a physical challenge for us. And right now it is available, what we can say, the forms. Suppose if we are getting these hydrogens from the coal, burning of the coal, then we can say that this is your the gray hydrogen. If we get the hydrogen from the renewable energy, then we can say that is it is a form of the green hydrogen, right? So right now I'm just going to tell you what are the steps, what are the sources from where we are able to get the hydrogen, right? So the steam and methane reforming, the partial oxidation, the thermal reforming, methanol reforming, pyrolysis, solutions on oxidation reduction of the biomass. This is also going to give you the source of the hydrogen gas, and electrolysis of the water. Yes, so this is very important, and this is what we can say very prominent method which is available for the generation of the green hydrogen, right? So if we are using the renewable energy like the solars, winds, or RES, then we can say this as a source of the green hydrogen. After that, we can say that the fermentation of the organic materials or thermochemical splitting of the water. These are the methods also they are going to implement, and they are also we are under the we have under the phase of the analysis on the research for more development and more for the reliable process. So just here how it is going to be worked, then we can see here. Just I have to prepare the small what we can say the one the short the graphic about, right? So we have put it the water, and one side we have given we are supplying the power cells and the current, right? So what happens, this water is going to be dissociated, right? So in the forms of what we can say, it is one side it is going to be collect the hydrogen on the cathode, and another side, that is the anode, where it is going to be the oxygen bubbles are going to be collected, right? So this is what we can say, the similar fashion and similar phenomena is going to be achieved in your electrolyzer, right? So right now the full focus and the full what we can say the plan and establishments are in going on, right? So that we can able to produce, right, able to produce the huge amount of the hydrogen. As still what I have observed and what I have physically I have noted that in the one trial basis in the NTPC in the Kawas in the Surat, they have started the generation of this hydrogen, right? But the scale right now it is very what we can say is very small, right? Just for what we can say it is a demo or a prototype on the basis, right? So we can able to achieve of this hydrogen in the form hydrogen as amount of in the kg, right? So the production of that amount of gases, it will take the roundabout your what I mean for that, it will take the 4 to 6 hours, right? So right now also we have to talk, also we have to emphasize that rate of hydrogen production, that we have to also we have to we have to increase a little bit, right? So now just we see the bubbles are coming from there due to electrolysis the process. The government faces for the hydrogen's energy, so that I have mentioned what are the steps we have taken in 2007 and in between of the 2017 to 2017, right? So just 1 minute. Once again, I'm just going to connect because there's some the PPT might not have been going to be changed. So just 1 minute. Now, everybody, please confirm that my slide is changing. Yes. Yeah, now it is changing. Okay, so these things just I have explained about the how the birth of the green hydrogen, right? So it is going to be generated and it is going to be collected on the form of the gases through the method, or the method is called the electrolysis process. So what we have the water, right? And we are going to supply this the current through your what we can say the voltage of the reliable sources of the electricity, right? So by this the process of your the supplying the current, your water is going to be dissociated in H2 and O2, which is going to be collected in your bubble columns that we called, or anode, or in cathode it is going to be collected. So right now what we have the problems that that I'm going to tell you that about the capacity is quite low, right? That we have to think about, and that's why it's the generations and the functioning that we have to more reliable. So for that in latest the development that we are going to achieve is about that we are going to add the cadmium wire, right? So that also going to be help in the little bit the more, right? Yes, now it is visible to all, right? Yes. So right now, what we have the facility to increase uh, mm, to increase the capacity of the hydrogen generation that we are right now. We have the latest development that we are going to done with the cadmium wire. Right now, we have to use how we can use this hydrogen gas in the boiler. Right. So for that, just I'm going to give you the outline that how we can make it. So in that category, just I'm going to share you one the method. This is your electrolyzer. So from here we are going to have the hydrogen storage, right? And then we are going to put in the our boiler and the furnaces, right? So yes. So here we are just going to what we can say the some we have the automation systems, and we also have the some safety equipment also we are going to introduce there, because if there will be the hydrogen will leak, then it is going to be the huge amount of the losses are going to be carried out, right? So high sensitive the leak detectors we are using, right? So hydrogen gas detectors that is going to be provided to the CI, and hydrogen leak detector systems which will give you the alertness and also give you the alarm to prevent these the leakages, right? So the challenge with the green hydrogen, the drawback of hydrogen as a fuel, so electrolysis and the steam forming, the two main process of hydrogen's extractions are extremely expensive, yes, right now. And the second part is that we have to store at very high pressure, right? So if pressure is around about 350 to 700 the psi, right? So it is not right now, it is not giving you the much economical, because the storage and for transportations it is going to be what we can say, it is going to be very expensive in the way compared to the other gases. The hydrogen leak smells which make a leak detections also is, it is a little bit impossible. So that's why we have to put a very significant and very accurate equipments, and we have to also we have to go through the time to time, it's the calibration, right? So that in the future and round the clock of 24 hours or 365 days, there should be no any what we mean for that the accidents or the hazards, the scenario must be avoided. Apart from that, we also going to work out right now. Just I'm going to share you once these details of productions, how we are going to produce, right? So renewable energies we are getting, right? After that, we have to go through the electrolysis process. So this is form, we are getting the formation of the hydrogen here, and here we are doing the transportation, right? So transportation, transformation, transportations here, shipping, trucks, pipelines, or a storage we can do. Then we can utilize in the industry what we can say in the steel sector, cement, chemicals, refineries, transport, aviation, car, trucks, buses, heatings area, and power generation. These all are the energy intensive areas where we can use this hydrogen energy. Next is very important about what we can say for the important thing that is related to for this the hydrogen purity. So the hydrogen purity must be we are using the TCD detector, which is in the range of 99 to 100%, right? So with these methods, the trace impurities such as argon, oxygen, nitrogen at the sub ppm level must be measured in the PED, right? So this is what we can say. We are going to take the samplings and precise. We are going to monitors of the purity of hydrogen, right? Because if what happens if the impurities is going to be occurred, then there is what we can say the main issues with with the first impurities and major portion, your moisture will be moisture contamination will be occur, right? So if the moisture is going to be intact with the hydrogen, then serious damage, serious explosions are going to be taken, right? So that's why this purity is very important, right? So for that, We have also have the what we can say on high precise manners. We have the purging systems of the CO2 through the CO2, because the CO2 is your inert as a systems, right? So we have these systems, these hydrogens purity, right? Okay, so these systems will going to be help in the greater way, so that we have to minimize or we can correctly or efficiently we can monitor the purity of this hydrogen. Right now,
હવે આમાં એ લોકોના બધા ફંક્શન અલગ અલગ હોય ને સાહેબ આમાં કોમ્પ્યુટરમાં આપણું હોય તો મારું પોતાનું લેપટોપ હોય તો હું ગમે તેમ કંઈ કરી શકું.
अब जा रहे हैं?
ऑटो मोड पे तो सर के बाद
That's why this the purity of hydrogen is very important, because just the 0.001 ppm of the moisture is going to be lead to the huge amount of the explosions and the dangers for the industry. So right now, just I'm going to connect about the what we can say the cost, which is what we can say the time to duration and the development. Right now, it is the in the decline segment, right? But still, we have to work on the rate of the productions, rate of the production of the hydrogens, and scale the size of the electrolyzer, right? Because just what we have the, the in the on the global or international level, the Germany has started this hydrogens in the use of the train, right? But if you go through the details of that the case study, I must tell to you that right now the rate of production of hydrogen is what we can say in the very lower segment, so that we have to improve, right? So that study is also going that how we can use more we can increase the rate of hydrogen production. Here I'm going to state about that the green hydrogen mission that is going to be provided by the government of India. And government of India in this the budget also, they have allotted of the 20,000 crores of rupees for the development, for infrastructures, for the supply chain, and easily ability to the access of the industry, right? So just I'm going to state about the green hydrogen the missions, right? So in this the format they have mentioned about the green hydrogen and ammonia manufacturer can purchase the renewable power from the power exchange or set up a renewable energy capacity themselves or any other developed anywhere. Open access will be guaranteed within 15 days of the receipt of application. The green hydrogen ammonia manufacturer can bank his unconsumed power up to 30 days, and distribution company take it back when required. Distribution licensees can also produce and supply the renewable energy to the manufacturer of the green hydrogen, green ammonia in their states of the console prices, which will only include the cost of the procurement, the billing charge, and the small margin as determined by the state commission. The waiver of interstate transmission charges for the period of the 25 days will be allowed to the manufacturer of the green hydrogen and ammonia for the project commission before the 30 June 2025. Government is also going to be benefit for the renewable purchase obligations will be guaranteed incentive for hydrogen production and ammonia manufacturer and distribution licensee for the renewable energy. Ensure easy of doing business is a single portal for carrying out all activity, including the statutory compliances clearances in a time-bound manner will be set by MNRE. Connectivity at the generation and green hydrogen, green ammonia manufacturing to ISTS for renewable energy capacity set for the purpose of manufacturing green hydrogen, green ammonia shall be guaranteed on the priority basis. The manufacturers of green hydrogen, green ammonia shall be allowed to set up the bunker near the port for storage of ammonia and hydrogen for export use by the shipping. Land of storage of this purpose shall be provided by the respective port authority as applicable charges. So the missions for the green hydrogens by the government directive are much more fruitful and supportive to move on. The latest is about the development of the hydrogen energy in India. The hydrogen energy is set by present by the research and development and the stages. Right now, the MNRE has going to be several the technology development and R&D development across the nation, which is going to subsector wise and subsystem wise, so that it is going to be more and more the production and storage and utilization the facility we can develop. Some more projects which is under phases and which may be coming time, it will be on the surface. Some development are going on. ICMFR Dhanbad, development and demonstration of hydrogen fueled three-wheelers, BHU Varanasi, development demonstration of diesel hydrogen fueled SUV, that is Mahindra and Mahindra. Mission mode project on hydrogen production through biological routes through IIT Kharagpur. Mission routes projected on hydrogen storage material hybrid R&D BHU. Mission mode project on the hydrogen storage in the carbon metallurgy in IIT Madras. So these are the some what we can say the segment wise development is going on, which will be the work as a utility for this hydrogen storage, transportation, and more productions for that. So this is what we can say. Here I'm just going to tell you about the conclusion part. Right now, the fuel. This is why the main factor is about which is going to be more promising of this hydrogen fuel, that is will have your high heat value, right? And second most important the thing is about that is their byproduct or the emissions issues are going to be nullified, right? So this is the major factor, but still we have the concern about the proper and proper use of hydrogen, proper production of the hydrogen, storage, transportation, right? So entire of the supply chain system must have to develop, have to be the rate of production is going to be economical, right? The technology development is also required, because still we have if we talk about this the green hydrogens, right? So this electrolyzers we are going through that method, but other methods we have to parallelly we have to evaluate, so that we can get the maximum of maximum the output, or maximum to maximum the rate of hydrogens we can achieve. So this was the little bit update about. Right now just I'm going to conclude here, right? And due to my some slides I have explained, but suppose it is not going to be moved as due to some internet issues, so I'm pardon for that. But just I'm going to connect to one important slide that you give you the much more detail about, and which is going to be connected, which is have the latest the development, and which is going to lead that tremendous development has occurred, which is right now it is going to be hydrogen is going to be work as the what we can say as a internal combustions, right? So hydrogen in the first time it is going to use as a internal combustions in the trucks. So just that I'm going to share one small the video about that. So thank you to all. Thank you to all the participants, and we both are available for your the open-ended questions, right? So just you raise your hand so that we can proceed for your question answer session, right?
Very good afternoon to all of you. Hopefully, I am audible.
Yes, yes.
Am I audible?
Yes, sir. Please proceed, sir.
Yeah. We can go for question answer session as said over here. I think we have two sessions from Mr. Kamlesh H. Patel and also Mr. Dinanath. Both are very wonderful sessions, and I think the information whatever received is very valuable. Good question answers are here displayed on the screen. So few of them we can able to take definitely. So I will start with this. Dr. Bhaskar V. Bhatt is saying that how it is envisaged to affect the sectorial move. Part of the question is not visible over here, but last part, how it is envisaged to be affected the sectorial move. This is might be the question to Mr. Kamlesh. So, sir, can you highlight something related to the green economy? What you are saying is how it is helping or affecting on the sectorial moments. And in connection with that, I think another question is there, which is asked by anonymous attendees. What is the correlation of GDP and low carbon economy? These two questions
Yes.
might be the
Yes.
speech delivered
Hello.
by the Honorary Minister Gadkari ji. So, sir, you can.
Hello. Voice. Voice. Yes.
Yes, sir, you are
Hello.
audible. You are audible.
Yes, sir, you are audible.
You are audible, sir. Patel, sir.
Yes, yes.
You please.
Can you say something related to, sir, low carbon economy and GDP relation?
Hello. GDP. Hello. As the GDP increases, hello.
Yes, sir. Yes, sir.
You are audible, sir. You please carry
Hello.
on.
GDP increases. GDP is increases means directly it is implemented the development or source the development, and as the development is more, then we have to focus on the green carbon economy also, because we have to take measures. I have also mentioned in my one slide that 80% of the population will be shifted to the cities area, and the population is major problem at that time as the GDP is increasing, and that's why GDP is increases in that concern. That I am explaining the low as hello. Yes. Hello.
Sir, you are audible. You please carry on.
Okay, sir. I think we can move towards the second question. What is the advantage of low carbon economy or low carbon circulation economy? I think low carbon circulation economy will be shaping the future. Please discuss. This is asked by Biben Roy. And I think it is worth to have a discussion on this. I request both the panelists to share their views. First, Mr. Kamlesh Patel ji.
Okay, as I have mentioned that the low carbon economy is the future, because we have to reduce as the population is increasing to the areas, and the more pollution will be there, and that's why we have to shifted our conventional fuel to the non-conventional fuel for the energy production or other. I have also mentioned that the power consumption will be also more in that.
Yes, yes, sir. You are audible.
Low carbon economy. Low carbon economy. Sir, low carbon economy is the future.
I think there is some technical glitches. It's going to be shortlisted soon. Can we move towards the next question?
Okay.
Mr. Dinanath, if you are able to hear me and your system is okay, can you say something about this?
Pardon, sir, please repeat.
Here, the question is about the low carbon economy and low carbon circulation economy, circular economy.
Right, sir. So the circular economy and low carbon economy, the basic, what we can say, the difference in between of that. Suppose one side we have using the, what we can say, the more emphasis on the renewable energy, and the somewhere we can say the circular economy, which is based on the more and more of what we have the available energy systems. So in that we have to cut the carbon availability, and according to that we have to maintain, right? So in that point of view, we have to must to go with the balance of both, right? We have to balance of the both the systems we have to adopt, so that our the market will have, and the industry will always going to be to maintain the same amount of the resources and the demand, right? So what happens if the sudden we go with the low carbon, then what will be happen, the some vicinity or some, what we can say, the vacuum may be the created on the systems, right? So that we have to little bit we have to avoid that, and we have to go with the low carbon circular economy.
Very good. I think we can move towards the next question, which is very much relevant to the today's session. Especially it is on the battery waste. Yeah, we are talking a lot about electric vehicles, but what about the batteries after its service life?
Yes, absolutely, sir, because these are connected with the lead, right? And if
This
we go,
question is asked by Vimal Kumar Palsanawala.
yeah. Yes, so definitely, because these are going to be considered, and these are having the main component is the lead, which are present in our the battery system. Either it will be have the lead or the lithium component will be there, right? So these the component are the disposals we have to make the policy, and we have to also give the provided that there's some procedure, right? Or we have to also we have to float the some system that if their battery life is going over, then it is returned to the manufacturer, or returned to the what we can say, the OEM, so that it is the portion of its the battery is going to be utilized or recycled, right? So that it will not much going to harm or going to create the hazard to the environment and the soils.
Okay, very good. This time to move towards the next question.
Sir. So next question, please, sir.
Yes, somebody is talking about a production of hydrogen. From where we
Yes.
get the hydrogen? If it's not,
Sorry, sir.
if I'm not
Hello.
wrong, Mr. Narayanan is saying that what is the source of hydrogen?
Source of hydrogen.
Yeah.
Yes, so already I have mentioned in my slides, there are 6 to 7 the sources, or it is what we can say, it is a process, right? Okay, so this process will generate the hydrogen. It is not always what we can say, it is available in our atmosphere or in the abundance that we can use, right? So we have to create, or we have the process systems, like what we can say, the steam forms, yeah, methane reforming, or biofertilizations. So these are the some methods are there, right? Or we also using right now, which is more popular, we are getting that the electrolysis process, right? So these are the process through which we are able to generate the hydrogen, right? So if we are using the what we can say, the through the methane, or through the use of your the coal, then it is considered as a gray hydrogen. But if we are using the what we can say, the renewable energy, wind energy, solar energy, that energy are going to be used as an electrolysis process, and that in electrolysis process it is going to be converted into the H2 plus O2, then it is called your green hydrogen. Then similar way, the methane process, right? So if we are going through the methane process, then it is also going to create the hydrogen. So these are the some steps are there, or we can say there are different method through which we can generate the hydrogen.
Okay, very good. A similar question was also asked by another participant, Amit Chandra. And I think he also got the answer for this question. We are at the end of our question answer session. If still anybody is having the question, they can write it down over here. Or if possible, you can unmute yourself and ask the question to the respective panelist.
Yes. Yes, or if anybody have the query, then you can directly mail to me also. My mail ID is akela, akela boiler boiler@gmail.com.
Yes, sir. I request you can write down your email ID in the question answer box or message box also, so that
Sure.
you can able to see it.
Sure, I'm just going to mention in my here.
Yeah.
I have shared my mail ID, right? So if you have received, then it is just please note down. And because already we have crossed the time, so we can discuss in the further the sessions also.
Yeah, I think we have come to the end of today's lecture sessions. We have two faculties over here which are very good, excellent in their own areas, and everybody might have enjoyed today's session on the low carbon economy, which is very much need of our, mainly because of the ill effect of carbon dioxide, what we are experiencing now and future. It is very much severe if we are not taken care of it right now. Including the lifestyle to the industrialization, everything should be streamlined as according to the low carbon. For that point of view, these sessions are very much important and necessary. Hand over to the respective.
With kind permission from chair, one announcement is here. Candidates and participants who have all are here. We are thankful to all of you. For the e-certificates, our portal registration portal is open till tomorrow midnight. So anybody, if you have want to the e-certificates for the certificate of participation, kindly log on to our e-certification link and deposit your requisite fee, and the certificate will be forwarded to your respective email. Thank you, sir. Thank you.
So thank you everyone. Thank you, respected our IAI President Debnath sir, Chairman of Mechanical Engineering Division Board. I truly admire the topic selection given by the A.Y. Dadabhai Institute, head of the department, Mechanical Engineering, Patel Saab, low carbon economy. I just wanted to think that in budget 2023 also 19,700 crores rupees are been devoted towards the green hydrogen mission by our Honorable Prime Minister, and to reduce fossil fuel use. So this is the best initiative taken by the IEI, I must say, to hands upon or to boost upon this concept. I must say they have targeted to 5 million ton target of green hydrogen 2023 also. So I am very much thankful to the participants, our panelist, Dr. Mukund Bade sir from SVNIT is a senior faculty over there. We are very much thankful to the team of whole webinar, our respected chairman sir of IAI South Gujarat Local Chamber, and my dear participants. We are always looking forward for such type of great seminar. Always kindly join us in future also. Thank you. Thank you everyone. Jai Hind.
Thank you. Thank you.
Thank you all. See you.